Since we're taking an extra day to do this unit, let's go back to the Notes Exponential Functions, the two papers that you received on the first day of this mini unit. And so if you go to section 4, the very last part, it says writing exponential functions from real life data. And the steps that we're told to use are to define the variables, then calculate the rate of change, the r value, from y sub 2 minus y sub 1 divided by y sub 1. The y sub 1 is the original y value, the first y value. Then we're going to use our exponential model that we've used before to fill in this r that we've calculated with the initial amount a and raise it to the x power, and then calculate the desired value. So in A, the table shows the world population of the Iberian lynx in 2003 and 2004. If this trend continues and the population is decreasing exponentially, how many Iberian lynx will there be in 2014? So based on this table, the year, usually something related to time, is going to be the x value. Now that starts in 2003, so I want to use, it'll be easier to calculate if we say the number of years since 2003. So as I define the variable, I want to say number of years, but now I'm going to include since 2003. That makes 2004 1 year, so x would equal 1 in 2004, x would equal 2 in 2005, and so on. The y value looks like population of the lynx. So y is the population of the Iberian lynx. So next step is to calculate the rate of change. So if this is my y1, 150, and then the second y value, the second population count, is 120, we want to use this formula to calculate r. So r is equal to y sub 2, 120, minus y sub 1, 150, divided by y sub 1, 150. 120 minus 150 is negative 30. Negative 30 over 150 can reduce, divided by 10, gives you negative 3 over 15, divided by 3, negative 1/5. And then we could change that into a decimal and say negative 0.2. So we're going to use that as the r value. Now the initial amount of lynx in 2003 was 150. So this is also the a value. So as we write the exponential equation, we want to keep in mind the r value is negative 0.2 and a is 150. So the equation is going to be y equals, the initial amount is 150, and then we're going to take 1 plus, and the r value is negative 0.2 to the x power. 1 plus negative 0.2 is going to make for 0.8. Notice this is between 0 and 1, so this is going to be exponential decay. It's decreasing exponentially. So now, how many Iberian lynx will there be in 2014? So how many years after 2003 is 2014? Well, 2014 minus 2003 equals 11. So this is my x value that I want to plug into the equation. So I take 150 times 0.8 to the 11th power. Then I take my calculator and type in 150.8 to the 11th power. I hit enter. I've got 12.9 Iberian links. Well, I can't have 0.9 Iberian links. So this model is approximating, so we round to the closest whole number of links to say this is how many we expect. And so as usual, it's not a bad idea to write down the decimal and say, okay, it says 12.885. And so the answer, how many Iberian links will there be in 2014? There will be 13 Iberian links. Okay, it's your turn. See if you can apply this method to part B. So hit pause on the video. Now that you've tried it, your variable for x should be number of years. I think usually time will be the x value. The y value is the value of the car, or the number of how much the car is worth. Okay, so the first thing we have to do is calculate the rate of change. And so in this case, I started with $30,000 as the value of the car. That was Y1. And it became, the next Y value was $20,000. So R is going to equal Y2, 20,000, minus Y1, 30,000, divided by Y1, 30,000. 20,000 minus 30,000 is negative 10,000. And negative 10,000 divided by 30,000 is negative 1/3. So that's my R value. So as I go to write the equation, the value of the car, Y, is equal to the initial amount, 30,000, times 1 plus the R value, which is negative 1/3, to the x power. So 30,000, 1 plus negative 1/3, or 3/3 plus negative 1/3, makes for 2/3. The question says estimate the value of the car after 5 years. So I want to insert 5 as the number of years. So that goes in place of x. Then I go to the calculator. And say 30,000 times 2/3 to the 5th power. If you use a decimal instead of 2/3, if you want to just put lots of decimal places, like 0.66666666667. Alright, so the value of the car is going to be $3,950.62. The 7 rounds the 1 up to 2. So I write down $3,950.62 is the value of the car after 5 years.